Okay, first hour especially, it was an unmitigated disaster. Did not go well. I think that you got the information, but I want you to have the information anyway. I learned from it. So this class will be different than how I taught first hour. Okay? Not because I taught first hour wrong, but I feel like it can get better. So this is the live version of the class. Fast forward as you need. You have these bunch of numbers up here. I want you to find the mean, find the median. If you're wondering right now, man, I wonder if he's going to ask on the quiz, which is on Monday or Tuesday, depending on which day you're in. Will he ask me about the mean and the median? The answer is yes. You will have a question that is involving the mean and the median. So please go ahead and do this. I'm going to step in front so I can take attendance. Howdy. There's my face. I'm sorry for that. What, bud?
Yeah.
Good talk. Don't confuse me today. I mean, me too. Me too. More often than not, I am, man. Tab is using your camera or microphone. That's what it says. Oh, man. None of this seems like it's going to go well. Is this going to distract you completely? If so, you can find another seat. Am I still recording? Hey, I am. Nice. Go this way because I like my drink. Once you get your answers, double check your answers with your partners or partner. If you have questions, please ask. But talk it over with your partners. What I'd love for you to do is when you find the mean, give me the total so that we can all check our total. So when you add them all up, give me the total. And then have the number of numbers that you divided by, because that's really what the mean is. You add them up, you divide by the number of numbers. So give me a total, give me a quotient. Give me a total divided by however many numbers there are. And then still give me the actual number. Go about 1 more minute on your own, and then I want to hear you guys talking to each other. So, that was 1, 1, 2, 3, 1, 2, 5, like, what are you doing? Well, it's not right, bro. I'm a little confused, but it's all right. Doesn't take much to confuse me. What I'd like to know now is there anybody's calculator that when you're adding these numbers, besides Aaron's because he's not using my calculator, that is just going off the screen to the left instead of going down? Are you able to see all of your numbers? Is the question. Okay, perfect. So when that happens, for the math print, you want last. So when you add them all up, it will show down. Second, press mode. You go to math print, press across it. I think everybody else's should already be in Classic. But if you're adding and you can't see your numbers, let me know. Okay, so now I'll answer my phone. This is where you guys start talking. Make sure your answers are the same. This is Mr. Hans' facility. Sure. Does he need his stuff? Or what do you got? Perfect, thank you. Mr. Creech, walk this way so you're not in front of the camera. If you would like to use this as a step, you can, or you can step over. Which would you prefer? Okay, please don't fall, please don't fall, please don't fall. Good, okay. You're going to the office. Okay, so first and foremost, it's almost the end of the week. You don't have school on Friday. That's a big deal for you. I do. I'll be making nothing but, like, I think I have 7 hours or 8 hours on Friday that, no kidding, for about 6.5 or 7 of those, I will do nothing but make videos. So if that sounds like fun, you're wrong. Just throwing that out there. You're wrong. Like, I don't like that I can't see everybody because of this stool now. Oh, that's okay. Thanks. He's like, fine. Now you can see me. Here I am. Beak. I play that game with my son. So, find the mean. What symbol do I actually want for the mean? So go to your notes. Go to lessons 2. Go to lesson 4. What symbol represents the mean? And you should have heard me call it something different. Hey,
the X with the line over it.
The X with the line over it. Mean, and I call it X hat. Why? I don't know. Like, that is not mathematical at all. I am usually very, very mathematical. And I give you the mathematical definitions. X hat. Why? Why not? Okay, because if I say X bar, yeah, well, it's X hat. Okay? That's the mean. So now, I'm going to get my calculator. We're going to add, and you're going to double check me, because right now, statistics is a blast. I'm going to teach you a lot of easy tricks in the calculator to do this rather than having to add this all up. But right now, Engage New York doesn't want that. It wants you to get frustrated with the calculator. Why? But you know what? Somebody smarter than me, I'm sure, made this material. And I'm going to say somebody smarter than me, hoping that they truly are. So we say 3 plus 3 plus 7 plus 7 plus 8 plus 9 plus 15, 21, 21, 35, 35, 37, 48, 48, 48, 52, 55, 57, 81, 3, 85, 85, 91, 99, 100. Should give me 1,133. Oh. I saw some people go, that's not quite what I had, not naming names. Is that what you had? Okay, good. Okay, then we have to count the number of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Is that correct?
Yes.
This is how I find the mean. The mean is really the summation of the data points. So the mean is the sum divided by the number of numbers, which we call n. Question so far. So when I do 1,133 divided by 25, I get 45 and 32 hundredths is my mean. Another name for the mean is the average. Question so far? Here's a strange question for you. Maybe not strange. If I made a dot plot, right? I had all these scores. Let's say these were test scores. Hopefully not for my class. But let's say, because that's bad. It's bad. But anyway, let's say we made a dot plot. So we've got all these scores spread out. Where should 45 and 32 hundredths be on this dot plot? Approximately where?
More towards the middle.
Yeah, more towards the middle. A mean, the average, is one way to find the center of the data. Would everybody agree with that? It's one way to find the center of the data. Okay, let's find the median. The median, don't drink that. Why are you laughing? All you can say is, sure, Mr. H. No, now you're, man. Okay, let's hope that my shirt doesn't ride up. Here we go. So I start, it's in numerical order, 2-finger method. I start and I jump. Doop, 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 doop. So there I am. I've come together at 48. So my median is 48. I can tell two things based just off of this. Have we graphed any of this? Have we put it in a histogram? Have we put it on a dot plot? Have we done any of that? Please don't fall. Step over it. Please don't fall. Perfect. Now you can fall as much as you want because now I'm not going to get in trouble for it. I mean, I might, but now it's not my fault, if that makes sense. Okay. I can tell two things about this. I can tell you right now, because the mean and the median are very close together. They're almost the same. That this data, if we graphed it, would be symmetrical. It would show me something very similar to that nice bell curve. I know that because the mean and the median are very similar. So you already told me that the mean is the center point. What about the median? Is the median also a center? Sure. These are both two ways to find the center of some set of data. Sometimes the mean's the better way. Sometimes the median's the better way. When the data is symmetrical, Wrigley, which one do you think it's going to be? If the data is symmetrical, do you think it's going to be better to find the mean or the median to tell me the center of the data?
The median?
Good guess. Guess again.
Mean?
Great guess. Do you want to guess again? Okay, good. It's the mean. It's not the mode. It's a great mathematical word, though. The mode is the number that occurs most often, and we've got several modes. 3s, 7s, 21s. Oh, no. 48's the winner, which shouldn't have. Gosh darn it. Don't confuse people. The mode is 48, but that's not a good way to find the center. That's not the. No. The mode is not a good way to find the center. Brody. Okay. When the data is symmetrical, when it is distributed evenly, so that we have that nice bell curve, the best way to find the center is by finding the mean. Listen again. If the data is symmetrical, the best way to find the center is to find the mean. So let's go the converse. If the data is not symmetrical, which means it's skewed, what would be the better way to find the center? Come on. I need every hand up because we should know this. Go ahead, Coop.
Median.
The median. If the data is skewed, the better way to find the center is the median. So symmetrical, mean, skewed, median. Everybody with me? Okay. So, may I erase what we have on the board? Does everybody have this? And I love that a lot of you wrote this stuff down, which is fine, but you're going to see it in your packet anyway. Go ahead and get your packets out while I hand out the test. Please go to Lesson 2's lesson summary. So go to Lesson 2, go to the lesson summary, please. The class average on the tests were, for the most part, relatively good. We had a class average of an 80. That should tell you a couple things. One, if you're above an 80, you brought that average up. If you're below an 80, you did not bring that average up. That means you need some help. I am here every morning at 7:05 waiting for you to get help. I am here via email. Every day, pretty much at all hours at night. I think I responded to a parent last night at like 10:30. My wife had to say, "What are you doing?" Because I'm typing this long message laying in bed on my phone. She's like, "What are you doing?" Like, I'm writing an email. She goes, "It's 10 o'clock at night." I was like, "Well, I love you guys. So, no, if I can help somebody at 10 o'clock or answer a parent's question, guess what I'm going to do? I'm going to do that." And I think if we want to get very specific with the average, I think the average was like a 77.87 or something like that. So it wasn't exactly an 80, but you get the idea. So right now, are there any quick questions on the test? I would much rather go over the test one-on-one with you, but is there anything that you're looking through and you're like, man, doesn't make sense right now, you better help me? Because I have high anxiety. So if I get something and I'm like, I don't get it, guess what? My mind, I can't move on. So if there's something that you don't get, I'd love to help you right now. If not, go ahead and open your packet 2 problem set or to the lesson 2 summary, please. So we're all right with our test for right now? If you have questions, you'll ask me later, which is fine. Remember, if you need to, I can stay. Well, I stay after you guys leave. So if you can get a parent to come pick you up, I'll help you. That's not what I want. That's what I want. Lesson summary. This is what I have already taught you. When did I teach it to you? Well, first off, I taught it to you during the lesson, if you watched it, which if I come around and I look at your notes, some of you didn't watch it. But neither here nor there, you should watch it. The lesson summary says, a dot plot provides a representation of a data distribution. Well, so does a histogram, so does a lot of other things, but it does represent a nice, easy way where we can see our bell curves. The mean and median, which you've already told me, are a great way to find the center. What's not a great way to find the center, Brody? The mode is a bad way to find the center. Sometimes we get lucky, but it's a bad way to find the center. The mode has nothing to do with the center. When the distributions are nearly symmetrical, okay? Not exactly, because no data is going to be perfectly symmetrical. If it's something from the real world, we will very rarely have something that gives us a perfect bell curve. It might be a little hump there. It might look like a little bit of a camel, but it's not going to be this hump, then up, then like, it's not going to look like mountain ranges. Everybody with me? When it's symmetrical, the best way to find the center is the mean. If you think you're going to have a question where I say, what's the best method to find the center? You are correct. So on their quiz, am I going to say, well, what's the best way to find a method? And it's going to be symmetrical, and you're going to say the mean because it's symmetrical. Correct. What if I have a data that's skewed to one side, and I say, what's the best method to find the center of the data? You're going to say the median. Why? Because it's skewed. That's what this lesson summary is about. Questions, concerns, problems. Okay, so we are now, again, looking at some questions that you can possibly see on the test. Quiz. Thing. I'm not going to read all of this. All I'm going to say is there's female scores, there's male scores. It wants you to make a dot plot. Okay, so before you start, I use X's, you don't have to. So here's my female scores. I would put 10, I'd put 20, 20, 20. Okay, you are going to make a dot plot for the females, the males. Before you go to both, I want you to keep working on this. So you're going to do the females, the males. I want you to find the mean and the median for both of these. Okay, once you've done the data, the mean, median, then you can go for all of them together. Questions? Do I need to repeat myself or are we good? I need to see visual representation with a thumbs up if you are A-okay with what I'm asking. Go ahead, again. Thank you for not drinking this. So once you've actually graphed the data, that's when you should start talking to your partners so you can figure out the mean and the median. And then you should start thinking, well, what's the next question the Mr. H is going to ask me? What do I know about my data? What does it look like? What was the whole purpose of lesson 2? You probably only need like another minute or two to finish graphing or plotting. And then I expect to hear you guys start to talk. Bless you. Yours. Okay, so start talking. Tell your partner what you're doing. What are you finding? How are you finding it? I want you to use some mathematical language right now. Don't just start plugging things into a calculator. Tell your partner what you're doing, please.
That's what I did. In between, I rounded up if it's 45, but I.
Double check your work with your partners. It would not be good if you guys have different means or medians. And then think about what could be the next possible question that Mr. H could ask. If I found my mean, I found my median. What does lesson 2 talk about? Symmetrical, skewed, center point. Okay, so maybe, what am I going to use? Let's go about 2 more minutes to make sure you get your means and medians for both. Once you have your mean for the females, find the median. Once you have your median, find the mean for the males, find the median for the males. Excuse me. Okay, so take a look at what we have here. All I want you to do is take a look at the females and the males distribution. What can we say about the females distribution and why? What can we say about that data plot for the females? Jason, what do you think?
The data is skewed to the right.
Okay,
It tells the-
so skewed to the right, tail to the left, I love it. What I didn't see in this class that I saw a lot in my first hour, and it's not a knock on you, it's they started thinking already. The reason why I like histograms, why I like this, is because we can start to see that actual bell curve. So if I do this, you should be able to look at that and say, this is not symmetrical. If I cut this in half, something is wrong, right? So when it's not symmetrical, that means it's got to be skewed. Jason said, hey, it's skewed towards this right-hand side, and it absolutely is. So right there, knowing that it's skewed should tell me something, but we're not there yet. Let's take a look at the males. How about the males? What's that graph look like? Is he? Yeah, it looks very symmetrical. Is it perfectly symmetrical? Absolutely not, because it's still data. We're not going to get perfect data. If you're getting perfect data every time, you're probably not getting the data from the right sources. Okay? So even though it's a little off, for the most part, if I did this correctly, it looks symmetrical. I could split this down the middle and say, okay, we can fold this on. So we know the females are not symmetrical. We know the males are relatively symmetrical. Have I lost anybody yet? So now let's find our mean and our median. Who thinks they know the mean for the ladies? Who knows the mean for the females? And I should see a lot more hands than this. Aaron.
54.93.
54 and what?
0.93.
54 and what?
93
hundredths. Okay. So they rounded. The mean is approximately 54 and 9/10 or 54 and 93 hundredths. Give me a thumbs up if we got that. Okay. The median is 65. So a question on your quiz on Monday will be to put the data points on there. It will be to find the median. It will be to find the mean. And then it will be which is the better choice to find the center, the mean or the median, and why. For the females, it's the median because the data was skewed. The males had a mean of 32 and 6/10. The median is 30. Notice how close those are. That's very similar to our warm-up, right? We had 45 and something and then 48. They're close. That means that the data was symmetrical. Still with me? So if the data is symmetrical, the better choice would then be the mean because the data was symmetrical. This is lesson 2. What's the better choice for the center? The average or the middle? Question so far. So now we get to the hypothetical. Why is it tough to try to find a center for the males and females together? Think about what you've already told me. You've told me the females are symmetric, and you've told me the males are skewed towards one side. So let's think about that. Let's go here. So here's the symmetric, here's the skewed. If I try to find the center, where's my data? Is there data here? So because we had two completely different data sets that had two completely different results, it would be hard to try to say, well, I want to use my center because it's still symmetrical here, but then it jumps back up over there. So there's really two different centers because we have two separate data points, which is why statisticians like to break data apart and have subcategories of females, have subcategories of males, because it gives us a better idea of what's happening within that knowledge. Whereas here, it's harder for us to say, oh, well, the scores are typically here. Like, we don't know. With the females, we knew the scores were typically higher. For the males, we knew the scores were typically lower. Questions? Okay. So, keys to lesson 2. Symmetric, better center is the mean. Skewed, the better center is the median. That's it. Go to lesson 4, please. You go to lesson 4, Mr. H. I will do that. So, side note, can I tell you how much fun I had last night? So, we finally found our Alexa, like our big Amazon Alexa, that since we moved. So we moved from our house in September, the beginning of October. It's now the almost middle of November, and we're still pulling stuff out of boxes because we're not. It's hard to try to unpack all your stuff because we know we're only going to be there for like 7 or 8 months. Like we know that we're moving into a brand new home. It's our forever home. So we're like, yeah, we don't really want to unpack. Like our house is trashed. It's fine. But last night we made blueberry muffins with Cole, and we made chili because it was cold. It was windy. We were like, oh, we're just, and we played winter break music for the first time. And I'll let you think whatever winter break music you want, but it was winter break music. And we all sat in the kitchen. We ate chili on the floor. It was so much fun. And my wife's like, it's not even Thanksgiving and we're doing this. I was like, yep. And it was Christmas, or I'm sorry, it was country winter break music. And I sang at the top of my lungs. And a neighbor came over and asked if we were playing winter break music. I was like, I am. He's like, I can hear you. I was like, good. How do I sound? And he's just like, loud. Like, okay, good. And he walked away. I was like, wow, good, got it. So that was our night. It was fun. Just throwing that out there a little tad bit about me. So the key to lesson 4 is this word, which is deviations. I may be wrong in this, but I believe it was Mike Tyson. Okay, so I boxed a lot. Like I had 77 or something amateur fights. I had 5 professional fights in boxing. I had another 50 amateur fights in Muay Thai. Like I fought a lot. Mike Tyson once said, everybody has a plan until you get popped in the face. And it sounds good. And as a professional, we had plans. We knew what my strengths were. My reach is very, very small. So I can't stand on the outside and pop somebody with a jab. I can't do that. I had to work my way in, maybe throw that jab, and then get in real quick so that I could use my uppercuts and my hooks. So we use these kind of things. And my plan was, listen, you get inside and you bump them with that shoulder until they're up against the ropes. And then you unleash as many punches as you possibly can. Are you going to get hit? Yep, but you got a chin. And I did. I could get hit pretty darn hard. There was only twice in my whole career that I got knocked down. There was many more times where I went, oh, I don't see straight right now. I should go this way. And then I'd lean up against the ropes. That happened. There's a reason why I stutter at night. I've been hit in the head a lot. Like, I get it. But I didn't deviate from my plan as a professional. As an amateur, I deviated from my plan a lot. Because guess what? As a 15-year-old kid, when somebody punched me in the head in the fight and it hurt, all I wanted to do was punch you back. And it didn't matter how I punched you back. It was, ah! And I was going at it. I was going to town. And I'd get into the corner. My coach would be like, what are you doing? I'm like, well, he hit me. He goes, yes, it's a boxing match. He's going to hit you. And like, this was my first match. He's like, so how tired are you? I was like, I can't lift my arms. He's like, well, you have 2 more rounds. So you got to figure out how to get your arms back up. And I did. I mean, it was a bad fight. It was bad. Like so deviate. That's really what we're going for. Deviation from the plan. As an amateur, I deviated from my plan a lot more than I did as a pro. As a pro, I knew that I couldn't deviate from my plan. What does the word deviate mean? I've tried to give you a lot of contextual clues. What does the word deviate mean in that context? Deviate from the plan. Jason?
How, like, falling apart from the point you're trying to be at.
Okay, so trying to stay on the path that you're going with, not going away from. So my plan was here. I didn't want to go this direction. I didn't want to go this direction. Deviation is the same thing in statistics. We have a center point. How far away are we from the center point? Deviation is x, which is a data point, minus x hat, which is my mean. This is deviation. You will absolutely need to know deviation. If you do not already have this written down because you did not watch the videos, you should be watching or writing it down right now. Deviation is how far away is something from the center. But in this case, the center is the what? The mean. How far away are we from the mean? This is one of the things that I look at and use statistics for your tests. Okay, because if my mean is 78, do I have most of my scores around a 78? Or do I have a 78, several hundreds, a bunch of 32s? Like, how far away are we from that mean? Do I have outliers? Sure. But for the majority, I know that my scores are between like a 72 and an 86. How do I know that? Because of the deviation. So, go all the way to your problem set. So, here are my stuff. We are talking about a girls' basketball team that's studying. Here's the number of hours that they study, which is cool. Okay? I want you to first make a dot plot based on those hours, calculate the mean study time for those students, and then calculate the deviations. So you need to find the mean before you can do the deviations. Will your deviations be positive and negative? Absolutely. Because negative deviation means it's below the average. A positive deviation means it's above the average. Go ahead. Talk it over with your partners. Let's see what you guys can get.
Yeah.
Now you still need to find the deviations. This is where you're taking the data point and subtracting the mean. Some of them are going to be positive, some of them are going to be negative. Don't forget those negatives. If you think that this could be a type of question that we would see where I give you data points, I then ask you to graph them or plot them. Then I'd ask you, hey, what is it symmetrical? Is it skewed? What's better, the mean or the median? Then if I asked you to find the deviations, could you do all that? Yep. So this quiz really isn't going to have that many questions. It's just going to have a bunch of parts. There will probably be 2 or 3 questions, but there will probably be 4 or 5 parts to each question. We will have time on Monday where I will review with you first. It won't be just jumping into the quiz. I will review with you all of the material, and then we will go in. Okay, and then we'll take it. Okay, so taking a look. Our data plot should look like this. Our dot plot, not data plot. We should have a mean x hat of 11 7/10. To find the deviation, we are taking the x value, which is our data point, minus our mean. So 20 minus 11 7/10. Double check my math, should be 8 3/10. 13 minus 11 7/10. Should be 1 3/10. Still good? Okay. 10, this should give me negative 1 7/10. 6 is negative 5 7/10. Is that correct? 13 is back to 1 3. 10 is back to negative 1 7/10. 13 is 1 3. 11 is negative 7/10. Negative 7/10, and negative 1 7/10. Okay, so this is importante. Okay, because we now want to talk about variability. Variability is easily seen with deviation. Are most of our deviations close together? Most of our deviations are within 2, plus or minus 2. 1.3, negative 1.7, 1.3, negative 1.7, 1.3, 0.7, 0.7, 1.7. Do we have 2 outliers? Absolutely. The negative 5 7/10 and the 8 3/10. But the majority, 80% of our data, is close together. That means that the variability of this is not very big. Let's do another example. iPhone batteries. If you get a new iPhone, we're just talking about iPhones in general. You get a new iPhone, that battery might last you 72 hours. My battery lasts 12 hours. Maybe Tippy's lasts 400 hours because she does nothing with it. It sits on a desk. Okay? My wife's iPhone, my phone's going off for some reason. My wife's iPhone lasts about 30 minutes. Is there a lot of variability in those numbers? 430 minutes, 12, 24, 40. They're all over the place. So that would be great variability. Right now, most of our data is centered around the center. If I was looking at this as a test grade or a warm-up, I'd be all right with this because most of my scores are all around the same place. Is there outliers? There's always going to be an outlier in data for the most part. So now my question is going to be is go to letter D. And now we're looking at, what is it, soccer girls? Is that correct? So now take a look at the soccer girls. Do you think their deviations, without doing anything else, just by looking, are their deviations going to be greater or smaller than what we have here, and why? So talk it over with your partner. I want to hear what you have to say. Are they going to be greater or smaller, and why?
Higher study.
So will the deviations be greater or lower? That means, will they have more variability? So will this have more variability? Okay, Wrigley. Wrigley's like, please don't talk to me ever. I'm sorry, Wrigley. So we're looking at this. Do you think that this variability is spread out or is it real condensed?
It's more spread out.
It's spread out. So this definitely has a greater variability. As soon as I say it has a greater variability, I know that it's going to have greater deviations. But why? Well, just by looking, let's make a guesstimate. Where do we think the average, the mean, is going to fall? Just by looking, if I was trying to balance this on one finger, would my balance be here? Or would it tip that way? So I can probably put it right around here, right? Okay. If I put it at 14 or 15, most of my scores are within 2. 16 to 12. Wait a minute. I got, So if this is where most of these have been, where most of those are within 2, no. So this has greater deviations from the center. The more variability you have, the bigger deviations you have. If we're looking for battery life, if I'm looking for test scores, if I'm looking for, safety ratings on a car, do I want my Kia Stinger to go through the test drive where it crashes into the wall? One time, everybody gets severely hurt. The next time, everybody's perfect. Then only one person gets hurt. Then 2 people get hurt. Or do I want it to be safe, 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 safe? I'd much rather have all those safes than one time I have a chance of being one time I have a chance of being great. I don't want variability in the safety of my car. I don't want variability in the number of tests that are passing or failing. I want those numbers to be close. Variability means it's spread out. The deviations, the difference from the mean is spread out. We want deviations usually to be smaller. Questions, concerns, problems. So let's rehash for the quiz on Monday. What things are going to be on the quiz? Well, let's think. Lesson 1 was about symmetric and skewed. Do you think I will ask a question about whether data is symmetric or skewed? Absolutely. Do you think in that same data that I've made you plot, whether it's a histogram or a dot plot? I will not ask you questions on a box and whisker. I will not. So it's either going to be a dot plot or a histogram. Do you think I'm going to ask you to make one of those? Yeah, okay. Based off of that, I'll ask you whether it's skewed or symmetric. I'll ask you, what's the better term to find the center, mean or median? I'll ask you to find the mean and median. I will ask you to find deviations based off of the mean. I will ask you maybe another graph to say, okay, what's the differences between these? I'll ask you, why is one deviation greater than the other? I'll ask you about variability. Are there questions? We will review all of this on Monday. You will have this video, the live lesson, there if you need it. I will also post a couple other lessons because, let's be honest, I think I taught this well. You might not. I will probably post 3 or 4 videos. This video, a video for tricks with the calculator, if I can find one, and then I'll post somebody else teaching these lessons. That way, if you want to watch somebody else do it, I'm fine with that. You know why? Even though my ego is huge, I want what's best for you guys. So if somebody else needs to teach you the same material, so be it. Questions?